Okay, so I have investigation 2, and the first question is what type of triangle is formed when the diagonal brace is positioned across the frame? So the diagram for this is right here, and the triangle that's formed is a 3, 4, 5 because this side is 3 and this side is 4, and we had to figure out what this side right here was, and the only viable option for that is 5, so it's a 3, 4, 5, and it can be proven by the Pythagorean theorem because 3 squared plus 4 squared equals c squared, and 9 plus 16 is 25, and the square root of 25 is 5. And the next question is, draw a right triangle with the side lengths of 6 centimeters, 8 centimeters, and 10 centimeters, using a protractor to ensure that one angle is exactly 90 degrees. Now make and cut out 3 squares, one with 6 centimeter long sides, one with 8 centimeter long sides, and one with 10 centimeter long sides. Please place each square next to the corresponding sides of the triangle. So here's that diagram, and these are in inches instead of centimeters so you can see them better. And this is our triangle. This is the 6 side, the 8 side, and the 10 side. And question 2 also asks which side is the hypotenuse. So the 10 side is the hypotenuse considering that it's the longest side. So these are all of our squares, the 6 square, the 8 square, and the 10 square. Which square has the largest area? So the 10 square has the largest area, and this can be proven by finding the area of all the squares. So 6 times 6 is 36, 8 times 8 is 64, and 10 times 10 is 100. So 100 is the biggest out of both of them. Question number 4. Try to fit the squares you made for the 2 legs of the triangle into the square for the hypotenuse. Do the 2 smaller squares fit exactly into the 3rd square if you cut up the smaller squares? What can you say about the relationship between the area of the squares? So if you try to put these 2 squares into this one, they will fit, but they will overlap. And they won't fit exactly, but when you calculate the area of the squares, you find out that the area of these 2 squares actually equal the area of this square. And a squared is 36, b squared is 64, and c squared is 100. 36 plus 64 is 100. So that proves that these 2 equal this. And that is all. And next you will have Matthew and Aubrey with investigation 7.
Okay, so this is our poster board for investigation 7. This is the diagram for question 2. It says, draw a diagram of a 30, 60, 90 triangle with the shortest side being 1 unit long. Use your diagram to fill out the table of the 30 and 60 rows of the table. So we used this to fill out the 30 and the 60, and we used the 45, 45, 90 triangle from question 3. It says, draw a diagram of a 45, 45, 90 triangle with the legs that are 1 unit long for... Use your diagram to fill out the row of the table. Okay, so we used this to fill out this. And then for question 5, what do you notice about the sine and cosine values of the 30 degrees and the 60 degree angle? Use this observation to fill out the final row of the table by comparing it to the 0 row. Find the tangent by dividing the sine of x by the cosine of x. So here is the cosine and the sine values. The reason it works is because the sine of 30 is equal to the cosine of 60, and the sine of 60 is equal to the cosine of 30. And the tangent works because the sine of 60 divided by the cosine of 60 is equal to the tangent of 60. And for question 6 it says, what do you notice about the sine of an angle and the cosine of its complement, cosine 90 degrees minus x? Write a conjecture relating to the sine and cosine of complementary angles. Sine of an angle is equal to the cosine of its complement. For example, 30 and 60 from the last question.
For question 7 on investigation 7, it says, describe the range of values for cosine and sine based on your table. And so for the range of sine, it's -1 is less than or equal to sine x, which is less than or equal to 1. So that's basically just saying the values are between, for sine, the values are between -1 and 1. And this is proven on the table with 0 degrees having the lowest sine of 0 and 90 having 1. And so this is the same thing for cosine. It's between -1 and 1. This is proven with 90 degrees having the lowest cosine of 0 and 0 having the highest cosine of 1. And you can place any of the other values as x and the same will still apply. For 8, it says, what is the value of sine x plus cosine x for x equals 0 and 90? Is this relationship true for the rest of the table? The sine x plus cosine x for 0 and 90 both come out to 1. This is true for the rest of the angles and their complements. It's like for 15 and 75, they both come out to 1, and 30 and 60 both come out to 1, since they're complements. For 9, it says find the value of sine to the second x plus cosine to the second x for several values of x. What do you notice about the value of sine to the second x plus cosine to the second x? The sine to the second x plus the cosine to the second x is always 1. This is true for every single value on the table. For number 10, it says, what is the range of the tangent function? Make a conjecture based on your table and test it by calculating the tangent of some other angles with your calculator. Explain why this is the range of the tangent function. Since the tangent value is undefined, it goes to infinity, so it would be like with the sine and cosine earlier, except the tangent is between negative infinity and infinity.